Hello everybody, I am your Kiran Kumar from Nature of Physics. Today topic is latitude from the gravitation. Clearly step by step I will explain. Please watch full video, you will get clarity, and please do like and subscribe our channel for the more videos. See student, I am going to explain with neat diagram and explanation about the latitude of variation of acceleration due to gravity. See that first one is the plane passing through the center of earth and perpendicular to its axis of rotation is called equatorial plane. This is axis of rotation, this is the equatorial plane, this is taken as equator students. And next, latitude. See, latitude representing of an place is defined as the angle which the line joining the place to the center of the earth, makes with the equatorial plane. See student, I am going to explain the acceleration due to gravity with respect to position of the body at equator to the pole, so that the object is moving from equator to pole, so that at any point we are considering P. That point here two forces are acting. One force is taken as weight of the body is acting towards the center of the earth. Another force is the centrifugal force mr omega square, and net force is acting between the mg and mr omega square. And here at a point P, latitude making an angle phi student. So this is also similar triangle phi taken, and opposite angles also taken phi student. So that straight line is 180 degrees. From this phi value is less and remaining angle clearly represented. So 180 minus phi. So the angle between the mg and mr omega square is 180 minus phi, and their resultant is representing mg phi. So here g phi representing acceleration due to gravity, net force, net acceleration due to gravity. Mg phi is the net force and g phi represent net acceleration due to gravity due to the latitude. So that mass I am not considering, okay, only acceleration due to gravity is acting toward the center, and mr omega square, from this r omega square considering, and g phi is acting between the g and r omega square. I am going to find this relation by the parallelogram law of vector. See student, the parallelogram law of vector, the resultant vector is g phi, so that g phi, which is equal to root over g square, see there, plus r omega square whole square plus 2g into r omega square cos 180 minus phi. See there, okay. And next step, here r omega square whole square become 0 student. That I am going to find. See there, omega is the angular velocity, omega value 2 pi by t. Now omega, which is equal to 2 pi divided by t value is 24 hours into 60 minutes into 60 seconds. So one thing we have to notice here, denominator is maximum, so that omega value is minimum. So omega is neglected, okay student. And then continuation step, here omega neglected, nothing but this value should be equal to 0, okay. And g phi, which is equal to root over g square, and cos 180 minus phi is minus cos phi, so minus 2gr omega square cos phi I got. And next, g square I wanted to take common, that's why g square divided by g. See there, g multiplied and g divided, and continuation step, g phi which is equal to G is common, square root of get cancel. So 1 minus 2 R omega square cos phi divided by G I got. Okay, and then continuation equation G phi, which is equal to G into 1 minus 2R omega square cos phi divided by G whole to the power of 1 by 2. And continuation, next step here, binomial expansion I am writing 1 minus x to the power of n, in which x is very much less than to the 1, so that I can write 1 minus n into x according to the binomial expansion. Same formula is applying there. So the power n is multiplying with x. Here the power 1 by 2 is multiplied with 2r omega square cos phi divided by G. Okay, so that G phi, which is equal to G 1 minus 1 by 2 2r omega square cos phi divided by G. So that 2 get cancel, G is multiplied now. G phi, which is equal to G minus G r omega square cos phi divided by G. G get cancelled, student. And then continuation G phi, which is equal to G minus r omega square cos phi I got. This is I can write as equation number 1. Okay, student, and in this equation I wanted to replace small r value. So with respect to small r, with the n position, the particle is in circular path around the earth, because of earth is rotating with angular velocity omega. So the triangle is OPN. So that cos phi, which is equal to adjacent side r divided by hypotenuse is capital R. From this equation I can write small r is equal to capital R into cos phi is replaced in the above equation. So the resultant equation is now G phi, which is equal to G minus r omega square cos square phi. This I can write as equation number 2, students. And then continuation applications are there. The applications I am going to explain. The first application, case 1. In this, at equator, so that phi value, which is equal to 0, pole area phi is equal to 90 degrees, from equator to pole 90 degrees, students. And then the value is replacing, that is phi is equal to 0. Okay, so the continuation step now, that is G equator writing, G equator, which is equal to G minus r omega square cos 0. Cos 0 is equal to 1. So GE, which is equal to G minus r omega square. So this I can write as equation number 3. And continuation step, next one is case 2. At pole phi, which is equal to 90 degrees. So the continuation equation, that is GP writing, P represent pole, student, which is equal to G minus r omega square cos 90. Cos 90 is equal to 0, 0 into anything 0. So GP, which is equal to G only. This I can write as equation number 4. Now we can replace equation 3 in equation 4. So that equation 3 and equation number 4, equation 4 in equation number 3, we will get G equator, which is equal to G pole minus r omega square. This is the relation equation number 5, between the acceleration due to gravity at equator and acceleration due to gravity at the pole. And continuation step, next one is here at equator GE approximately equal to 0 considering, and related one problem also is there. Wait a second. See now, if the angular velocity of the earth spin is increases such that the body at the equator start floating, then the duration of the day would be approximately. Okay student, so related to this concept, the problem at equator G phi approximately equal to 0 given according to the question. So the value is replacing, we will get now 0 which is equal to G minus R omega square. This I wrote from equation number 3 student. Yes, equator condition case 1. So that R omega square which is equal to G, and omega square is equal G divided by R, and omega is equal root over G divided by R. This I can write as equation number 6. Okay, in this the values also I am replacing. So the values are, that is radius of the earth which is equal to 6400 kilometers. Okay, and then continuation, small g is the acceleration due to gravity, that is 9.8 meter per second square. Both the values are replacing, then we will get omega which is equal to root over 9.8 divided by R value is 6400 converted into meters, that is 10 to the power of 3. After solving this, we will get omega value is 1 by 800 radian per second units. 1 by 800 I got student. And then continuation relation, time period also I want to find here. So for that time period, see student, so from equation number 6, omega value is 2 pi by t which is equal to root over G divided by R, and cross multiplication 2 pi root over R divided by G which is equal to T student. So the duration of the day according to the question, duration of the day, so that is T which is equal to 2 pi root over R divided by G. In this equation the values are replacing. R is equal to 6400 kilometers and G value 9.8 meter per second square kilometer. 1 kilometer is 1000 meters, replacing in the above equation. The resultant equation T which is equal to 2 pi root over R value is 6400 into 10 to the power of 3 divided by 9.8. After solving this we will get 84 minutes. This is the answer for the given question. Please do like and subscribe our channel Nature of Physics for more videos. Thank you for your kind support.